We were asked in one problem to determine the number n, the integer n, for which n cubed plus n squared minus 810 equals 0. Now this is not an equation that you would expect to be able to solve using any standard method. But you're given a hint that you go back to the pattern for which the problem was designed. The pattern is 1 cubed plus 1 squared equals 2, 2 cubed plus 2 squared equals 12, 3 cubed plus 3 squared equals 36, and so on. And of course you can easily calculate these numbers. Now it just turns out that if we continue this pattern, we end up at some point coming across the 9 cubed plus 9 squared equals 810. Now we're trying to find the n such that n cubed plus n squared minus 810 equals 0. Since 9 cubed plus 9 squared equals 810, if we subtract 810 from both sides, we have 9 cubed plus 9 squared minus 810 equals 0. And we see that n is equal to 9. So that n equals 9 is the solution to this equation. And we simply use this pattern and establish the pattern, and notice that we have a line of the pattern that allows us to solve this equation. If this had been n cubed plus n squared minus 400 equals 0, we would have been out of luck because 400 doesn't appear in that pattern. Although we would have been safe in saying maybe that since 7 cubed plus 7 squared is 392 and 8 cubed plus 8 squared is 576, that the n such that n cubed plus n squared equals 400 is pretty close to 7, because 392 is pretty close to 400 and 576 is a lot further from it. Now we notice that the number 5,237 means what? In expanded notation it means 5,000 plus 200 plus 30 plus 7. Now 5,000 can be written as a power of 10. 5 times 10 to the third. 200 is 2 times 10 squared. 30 is 3 times 10 to the 1. 7 is 7 times 10 to the 0. Okay, and we note that there's a reason why 10 to the 0 equals 1. This is kind of a digression, but people keep wanting to call 10 to the 0, say it's 0. And usually in high school you're taught to memorize the fact that any number to the 0 power is 1. There's a very good reason why it has to be that way. Now, for example, by the laws of exponents, 10 to the 0 times 10 to the third equals 10 to the 3 plus 0, right? Because we add exponents when we multiply the same base. And that's important, and there are good reasons for that. It's the way numbers behave. Anyhow, 10 to the 3 plus 0 is 10 to the third. So 10 to the 0 multiplied by 10 to the third equals 10 to the third. Now, 10 to the 0 multiplied by number equals that same number. What's that tell you about 10 to the 0? Well, what do we multiply by a number in order not to change the number? 1. 10 to the 0 has to be 1. Okay, now, digressing, end of digression, but if we add 75 and 26, of course, standard way 5 and 6 is 11, we carry the 1, we get 8 plus 2 is 10. In expanded notation, we would write 7 times 10 to the first plus 5 times 10 to the 0, added to 2 times 10 to the first plus 6 times 10 to the 0. 5 times 10 to the 0 and 6 times 10 to the 0 gives us 11 times 10 to the 0. 7 times 10 to the 1 plus 2 times 10 to the 1 is 9 times 10 to the 1. Now 11 times 10 to the 0 is what? Well, just like the Egyptians, we've gone over 10 here. We've got an 11. What do? We take our 11 sticks and make a heel bone and a stick. That is, 11 times 10 to the 0 is 1 times 10 to the 0, 1 times 10 to the 1 plus 1 times 10 to the 0. Instead of heel bones and sticks, we use powers of 10. Now, we've got a 9 times 10 to the 0 plus 1 times 10 to the 0. What's that? Well, that's 10 times 10 to the 0. Or 10 times 10 to the 1. 9 times 10 to the 1, 1 times 10 to the 1 is 10 times 10 to the 1. So we have 10 times 10 to the 1, plus 1 times 10 to the 0. Well, there we got 10 heel bones. We got to make us a scroll. That is, 10 times 10 to the 1 is 1 times 10 to the second, plus 0 times 10 to the 1, because we don't have any sticks left over. Okay, we just got our heel bones. We don't have any heel bones left over. We got exactly 10 heel bones. We make a scroll. We got nothing left over. But we still have to write the 0 times 10 to the 1 because we got a place value system. And then we have our 1 times 10 to the 0. So this is a representation of how we would go about adding two numbers using expanded notation.